Hi, this is a pre-lab video for carboxylic acids and their salts. This is really a lab about drug solubility. It's important to understand the solubility of acids and their conjugate bases so that you know that when you inject a patient with medicine that the drug will still be soluble in their bloodstream. Before this lab, it's a good idea that you review solubility of solids, and you remember that solubility of solids depends on temperature. Also remember that ionic charges make drugs more soluble in water, and that acids and bases exist in different forms depending on pH. If you want to review this information, it's a good idea to click on the links that are available now. Okay, let's get started. In your pre-lab exercise, I asked you to draw salicylic acid. Here is the structure of salicylic acid. We've seen the structure before when we synthesized aspirin. This was one of the starting materials that we used. Salicylic acid has two main functional groups, a carboxylic acid and a phenol. The carboxylic acid is a functional group that you should know by now is a weak acid. The phenol is not an acid. The carboxylic acid has an acidic proton, and in this lab, that acidic proton is going to react with base. One of the first things you're going to do in lab is you're going to try to dissolve salicylic acid in water, and you're going to test its solubility depending on different temperatures. But then you're going to carry out a reaction where salicylic acid reacts with sodium hydroxide. What will this do to the solubility of salicylic acid? You have to remember that sodium hydroxide is a strong base, and when it is in water, it dissociates, just like any ionic compound. This one will dissociate into sodium ions and hydroxide ions. The hydroxide is a strong base, and the sodium is really just a spectator ion, or it does nothing, except for balanced charge. This is a strong base, and here I have a weak acid. The carboxylic acid hydrogen is an acidic proton. An acidic proton from the salicylic acid will react with the base from hydroxide. Pause the video now and draw the products. You should draw the conjugate acid of hydroxide ion and the conjugate base of salicylic acid. Okay, this is just a simple acid-base reaction. Hydroxide ion bonds to the hydrogen on salicylic acid, and it makes water. When the hydrogen ion leaves, it leaves behind a negative charge on the carboxylic acid. Sodium does not change, it's just the counter ion. This is the salicylate ion. Some people call this sodium salicylate because the sodium is the counter ion that balances the charge. Now think about what would happen if you took these products and added hydrochloric acid. If I took this, which is the conjugate base of salicylic acid, and I add hydrochloric acid, what would happen? This is a strong acid. Do you remember that strong acids dissociate completely in water? Well, they do. Hydrochloric acid will dissociate completely into hydrogen ions and chloride ions. This is a strong acid, and this is just a spectator ion. This strong acid will react with the salicylate base, which is the conjugate base of salicylic acid. So this oxygen will bind to the hydrogen ion. What will the product look like? Pause the video now and try to draw the product. This is just an acid-base reaction. While salicylate is the base, you should draw the conjugate acid, so salicylic acid. In this case, the conjugate base of hydrochloric acid is just the chloride ion. Sodium, again, remains unchanged. It's just there to balance the charge. So the products of this reaction are salicylic acid and sodium chloride, or table salt. Try to apply this concept to the question about octanoic acid. Octanoic acid is the fatty acid 8:0. It has 8 carbons and 0 unsaturations. It also has a carboxylic acid functional group, and the carboxylic acid functional group will always act as a weak acid. The acidic proton is the hydrogen that's on the carboxylic acid. Based on what you know about ionic charges and how they affect solubility of drugs, try to predict the relative solubility of the charged or ionic versions and neutral versions of the molecules that we just looked at. Thanks for watching this video about carboxylic acids and their salts. If you have any questions, feel free to post them in the comments, and please let me know if this video is helpful. I'll see you in lab.